So we've seen that there are two kinds of mixtures: homogeneous, evenly mixed, and heterogeneous, unevenly mixed. And we've also seen that heterogeneous mixtures contain discernible phases with phase boundaries between different regions. Now in chemistry, you'll often encounter two subclasses of heterogeneous mixtures: suspensions and colloids. A colloid is a very fine-grained heterogeneous mixture, something like blood or milk. The phases are tiny particles or droplets that can be as small as viruses or cells. The phases don't settle out or separate on their own. The mixture is stable. The phases are so small that you can't filter them out with ordinary filter paper. For example, if you strain a colloid like cream through a coffee filter, it'll come through without separating into butter and buttermilk. A suspension is more coarse-grained. Think of the snow in a snow globe. Generally, anything that says shake well before using is a suspension, because suspensions will separate and settle out on their own. So examples of suspensions might be muddy water, or oil and vinegar, or beer with a head on it, or pulpy orange juice. It's not always that easy to tell a solution from a colloid or a suspension just by looking at it. If you've got a heterogeneous mixture like water contaminated with coliform bacteria, how can you detect that? Well, use the fact that the phase boundaries in heterogeneous mixtures can scatter light. If you can see the light beam passing through a sample, phase boundaries are present. Now that's called the Tyndall effect. Now you've probably seen the Tyndall effect yourself if you've ever watched car headlights on a foggy night. You can see the headlight beam because a fog is a heterogeneous mixture of air and water droplets. So is smoke. You can see your car headlight beams in smoke. Clean air is a homogeneous mixture, so you don't see the headlight beams unless it's foggy or smoky or the air is otherwise full of particles.